So let's get on to the new bit for today. Measures of position. So the first one is very easy. Rank. It's typically what we think of when we think of position. Suppose you run in the New York Marathon, 12,635 people run, and you finish 586. First of all, congratulations. And second of all, your rank is 586. So that's very straightforward. Next bit. Quartile. What's a quartile? The idea behind quartiles is you break up your entire group into quarters. And you say, was I in the first quarter or the top quarter? Was I in the second quarter, the third quarter, or the fourth quarter among all the data points or among all the people? So now 586, which quarter is that in? First quarter, second quarter. So it seems like it's pretty near the top. But suppose I said, what about someone who finished 3,210? Well, this would require a little bit of effort, right? It's not immediately obvious. So what do we have to figure out? We have to figure out where these quartiles, where the quarter marks are, where the first quarter ends and the second quarter begins. So how do we do that? Well, let's see. All right. So in other words, what we need to find is the quarter point, the halfway point, and the three-quarter point. So let's do that. By the way, we've already spent some time finding the halfway point, because what is the halfway point called in statistics? That's the median. Exactly, Bruno. Because what is the median? Middle number. Middle is also the same as halfway. Okay. So the methods that we're going to use here are very similar, are almost exactly the same as, well, they're the same as finding the median, but we're now going to extend this idea. So how do we find, for 12,635 people, how do you find the halfway point, which is the median? How do we divide? Almost. It's almost divide by 2. Remember we had to make a little adjustment? Plus 1 and then divide by 2. Exactly. So if you do plus 1 and divide by 2, you get 6,318.
So you go 635 plus 1 divided by 2.
Yes. No. You have to do the plus 1. This is. It's difficult to give a clear, direct explanation of why you have to do the plus 1. We talked a little bit about this last time. Basically, we do the plus 1 because it works. Let me go back to the example just to remind you of what the plus 1 is from. Okay. So in this problem, there are 19 numbers, and we know from working this out. So we said this last time. You're going to cross out how many numbers on each side. You're going to cross out 9 numbers on each side. So you want the number in the middle, which is the 10th number. Well, how do you get from 19? How do you get the 10th number? It's not 19 divided by 2. That's off a little bit for some reason. So if you do 19 plus 1 divided by 2, that gives you the 10th position. So, like I said, it's hard to give a clear, direct explanation of where the plus 1 comes from, but at the very least, you should be able to look at that and say, oh yeah, using plus 1 works. Okay. Well, we're so happy with how plus 1 worked, we're going to use it for all these measures and all these calculations. So how do we find the quarter mark? From 12,635, how do we find the quarter mark?
Plus 1 divided by 4.
There you go. If you do plus 1 divided by 4, you get 3159. Okay. So that was the sort of more intuitive presentation. Now we're going to start talking a little bit about formulas so we can find all these things. And writing down, so the next thing I'm going to show you is the 5-number summary. The 5-number summary includes numbers that tell you all these things. The 5-number summary includes, for your data set, the minimum number and the maximum number on the ends, so it tells you where your data starts and ends. And then it also gives you the quarter mark, the half mark, and the 3/4 mark. And the notation for those are Q1, Q2, Q3. Right, and what does the Q stand for? Quarter. Quarter or quartile. Same thing. Okay. Right. So. Right. So again, for example, how do we find Q2? Well, Q2 is just the half mark. It's the same as the median. So it's in, you do n plus 1 divided by 2. It's in the n plus 1 divided by 2 position. We already worked on finding the median. We've already done that. And then, as Gordon just said, how do you find Q1? Well, Q1 is at the quarter mark, so what do? You take n plus 1, divide by 4. Exactly. Now here's the slightly tricky one that we need to think about. How do you find Q3? Q3 is at the 3/4 mark. Well, if you know where the quarter mark is and you know where the halfway mark is, then you're trying to find the 3/4 mark.
3/4.
Yeah, exactly. We're going to use 3/4. That's exactly right. So what I want to show you is that divided by 2 is the same as times 1/2. Does everyone believe that? Okay. Divided by 4 is the same as times 1/4. So look at that. In order to get the quarter mark, we multiplied by 1/4. In order to get the half mark, we multiplied by a half. So to get the 3/4 mark, what are we going to do? Multiply by 3/4. And there you go. So enough theory. Let's actually see how this applies to some actual data. So here's a data set. Let's find these numbers. So Q1 appears in which position? So how are we going to figure that out? What do we do for Q1? Right. So this is n plus 1. Right. So first of all, what's n?
12,000.
For this data set. What does n represent? Right. And by the way, it might help to remember that n stands for number. So it's the number of data values. How many do we have? 9. Okay. So Q1 appears in which position? Well, you start with 9 plus 1, and then what do you do with that? Right. Well, for Q1. Q1 is at which mark? Q1 is at which mark? Q1 is at the quarter mark. So what are we going to do? Right. Divide by 4, or to make everything look nice and similar, we're going to exactly multiply by a quarter. So you work this out, you get 10 over 4, that's 2.5. So Q1 is in the 2.5 position. 2.5 position, where's that? That's between 2 and 3. So you look at your data and you say, okay, what's in the 2 and 3 positions? So then how do we figure out the actual value that it's supposed to be? 15, 16, you want whatever's in between. So what's in between 15 and 16? $15.5. Now, what about Q2? Right. Q2 is at which mark? It's at the halfway mark. So we're going to multiply by a half. So this is going to be 10. Winds up being divided by 2, which is 5. So what number is in position in the 5th position? That's 18. That one's straightforward. Next, Q3 is in which position? It's at the 3/4 mark, so you take 9.1 times 3/4. You work that out, and you get 7.5. Now, how do we find the 7.5 position? Yeah, you look at 7, and you look in the 7th position and the 8th position, which is right here. So what number will that be? What data value will that be? 20.5. 2021 divided by 2, 20.5.
Can't you add up Q1 and Q2 to get Q3? I mean, like to get the 7.5.
That's a very clever shortcut, and you're exactly right. So that's a little comment about the +1, but we already talked about that. Okay. So now that we've done this calculation, let's write down the answer the way the question is being asked. So what is the 5-number summary? Well, remember, it's the minimum. What's the minimum number for this data set? 14. Then you write Q1, which was 15.5. Then Q2, 18. Then Q3, 20.5. And then the max, which is 22. Okay. So I've written down 5 numbers. What do they mean? Remember, the original idea was that we want to break our data set into quarters. So let's see if these numbers sort of look like they break our data set down into quarters. Okay. Well, you've got the min, which is over here. Then you've got the max, which is over here. Then you've got Q1, which is 15.5, which is right here. Then you've got Q2, which is 18, so that's right in the middle there. Then you've got the Q3, which is 20.5, which is right there. Does that look like it has sort of broken our data set down into quarters? Yeah, absolutely. So this is the idea. And in statistics speak, quarters are called quartiles. All right. So now we're going to extend this idea, because what we've talked about is the quarter mark, the half mark, and the 3/4 mark. But so we could so by the way, the half mark is what in terms of percent? 50%. And the quarter mark is what in terms of percent? 25%. 3/4 mark is the 75% mark. So we're now going to extend this idea to talk about not just those marks, but we can talk about the 60% mark. or we can talk about the 15% mark. How do we do that? Well, let's look at this data set and let's find the 37th percentile. So, actually, before we do that, so what we just said was that the quarter mark is the same as 25%. Now, how could you write that down as a number to make it look more like 25%? Yeah, 1/4 you could also write down as 0.25. So the quarter mark is the same as the 25% mark, so you multiply by 0.25. What about the next one? Sorry? Yeah, the half mark is the same as the 50% mark, so you're really multiplying by 0.5. So, in order to find the 37th percentile, guess what you're going to multiply by? And that's it. Let's actually go back and find the 37th percentile for this data set. What is the 37th percentile? How do you find it? 9 plus 1 times 0.37. And that works out to 3.7. Well, what do we do with that? Exactly. What position is 3.7? Well, it's between the third and the fourth. So what's in the third position? 16. What's in the fourth position? 17. So there you go. 16 plus 17 over 2. So it's 16.5. And that's how you do percentile.
You know that it's not exactly 3.5? Like it's not exactly
Yeah.
15.
So good question. We're just gonna simplify our lives and we're gonna. That's a good question. You could try to get fancy and say it's 0.7 is not 0.5. We're just gonna say 3.7 is between 3 and 4 and just treat it accordingly. Yeah. Keep it simple. But good question. So how would you find the 37th percentile? Let's look at this new data set. What's the first thing you need to figure out about this data set? Sorry? How many numbers? And what's the notation for that? N. Somebody counted up, N is 14. So how do we find the 37th percentile? (14 plus 1) and then times 0.37. And if you work, let me find out what that is. Equals 15 times 0.37. That gives you 5.55. So 5.55. What's that? Where's that? Sorry? Right. Well, it's between, just very simply, it's between 5th and 6th. So what's the 5th position? What's the 6th position? 15 and... Oh, okay. So this is easy, right? So it's between 15 and 15, so what number is that? 15. That's you just take the average, you get 15. Okay. So there you go. There's your answer. So now I'd like to see you guys find the 58th and the 78th percentile. So who can tell me something about the first one? Okay, Gordon, go ahead.
18.5 is a 58%.
Okay, and tell me how you got that, and let's see.
Like I did 14 plus 1 is 15. 158.
Okay. Okay. And Gordon, what else?
Then you go to the eighth number. 1,
Okay.
2, 3, 4, 5, 6, 7, 8.
Okay.
Yeah, I think we got right.
So what? And then what did you do?
I forget what I did.
You go to the eighth number, which is 18, and then what?
And then I went to 19.
Right.
And I divided by 2.
Is that good? So that's it. Yeah. For percentile, this is it. Is this the hardest thing we're going to do this semester? No.
Was the other one the hardest thing?
Yeah, I think
Uh,
it wasn't hard. It
hard.
was slow.
Yeah. Yeah. Okay. And then the 78th percentile. So like that. All right, is that good? Okay, so that's percentiles in one direction. Notice that in each of these cases, I said find the 37th percentile, and you said in the last, for example, in the last case, you said the data value should be 25. What if I went the other way around? And I'll give you an example. One of the very typical cases where percentiles are used are to figure out people's rank in the population. Very common thing is in terms of IQ. Another very common thing is in terms of height or weight. You go to the doctor and you say, like when if you have a kid, you take the kid goes to the doctor and the doctor says, oh, your kid's in the 78th percentile of heights or whatever, and then they can predict how tall they're going to be eventually. You ever see those growth charts? That's what they do. They track where the 78th percentile, what the eventual height will be. But in order to do that, you have to go the other way around, right? Because you have to say, my kid has such and such a height. What percentile are they in? So let's do that sort of calculation right now. So for example, what percentile is the data is x equals 24? So how do we do this? Well, to do this is actually quite easy. You just have to understand what percentile means. Percentile means percentile means that you are above a certain percentage of the data. So let's go back for a minute. The 37th percentile we said was 15. Well, if I mark off where 15 is, does that look like it's above approximately 37% of your data? Well, what's 37%? It's about a third. Does that look like it's approximately at above a third of your data? Ish? Approximately. What about the next one, 18.5? And mark off 18.5. Does that look like it's above approximately 58% of your data? Yeah. Should be a little more than half, and that's about what it is. Again, we're just eyeballing it to get it to make sure that this makes sense. Okay. So now the question is, if we mark off 24, well, what percentile is that? Which is the same as asking, how much data is it above? Well, approximately, but let's figure out. So approximately, you're exactly right. But we need to find a precise way to do this. So how much data is 24 above? Well, what position is 24 in? It's in the 11th position. So how much is it above? It's above 10. But 10 is not a percent. How do we convert that into a percent? 10 out of what? Not out of 100. 10 out of 14, because you have 14 data points. You do 10 divided by 14, you get 0.71. It's the 71st percentile. And that's it.
That's it.
Yeah. So that way is actually, I think, easier. The hardest part is counting. I'm sorry? Yes, it's in the 11th place, but the way we interpret percentile is to say how much of the data is it above. Yeah. Okay. So does that? I mean, I think that's pretty straightforward. Any questions on that?
What if someone was mistaken and start from the 24 level and do like 11 divided by 14?
That'd be wrong. Okay. Wrong by a little bit, but still wrong. Okay. So, 2 or 3 comments. First of all, now that you sort of know what this is, let me show you the notation for percentile. So notice that the last thing we said was the 71st percentile is 24. So in notation, guess what the notation for percentile is? P. Very good. So write like this. P71 is 24. Like this. So that's the first thing. The second thing is that notice for all these problems, the middle step is finding the rank. So for example, when we were finding the percentile, finding the 37th percentile, you have to find out what position you want. The position was 5.55, and then we figured out what data value it was. Likewise, going backwards, if your data value was 24, first you found the rank, which was 11, and then we did our calculation to find the percentile, which wound up being 71 or 71st percentile. So all these, so that's related. Okay. It's a second thing. Okay. Now here's another comment. This formula for finding percentile or whatever, it has some glitches for small data sets. So what's the problem? So one data value represents a large chunk of your data. For example, if your data set has 20 numbers, each number really represents 5% of your data. Now in the real world, you'd really be dealing with data sets that are like 1,000, 10,000, 100,000 people, and this isn't a problem. But when you're on an exam, obviously I'm not going to give you 10,000 a data set with 10,000 numbers in it. That's just silly. So the only small problem is you should just be aware that, for example, you go back over here. When I said calculate the 78th percentile, we said that's going to be in position 11.7. What if I say calculate the 79th percentile? You're going to get like 11.8. So it's really going to wind up being the same number. Why is that? It's not any problem with our methods, it's because our data set is so small that there's no difference between the 78th percentile and the 79th percentile. Now obviously if you're dealing with the United States population, there's going to be a big difference between the 78th percentile and the 79th percentile. So long story short, don't be bothered by this, just follow the formula.
So formula is always use +1.
Yeah. Okay. So any questions about these things that we did? Okay. So let's bring it all together and let's make a 5-number summary for the data that we were just working with. So I want to talk you through just the very beginning step, or a little bit of this anyway. So, first up, so remember, what is the 5-number summary? It's the Q1, Q2, Q3 with the min and the max on the ends. Min and max are easy. So let's look at Q1, Q2, Q3. So how do we find Q1? Right. Oh, so the first thing to remember is that how many numbers do we have? Our n is 14. Okay. So for Q1, what do you do? Right. So we could write down as 1/4. I want to update this so it's consistent with everything else. What is 1/4 written as a decimal number? It's just 0.25. And notice that if you think of it as 0.25, quartile, percentile, it's really all the same kind of calculation. Q1 is at the 25% mark, so you just multiply by 0.25. So when you work this out, 15 times 0.25 gives you 3.75. Okay. So I just want to start you off with that idea. Now I want you guys to finish up this exercise. Okay, so let's talk about this. So who can help me out with the next bits?
The second quartile would be 7.5.
Right, how'd you get? Oh, okay.
14 plus 1
Okay.
The third quartile would be 11.5.
How'd you get that?
11.25.
Okay. Okay. So is this the answer, or can you tell me the answer?
No, the answer would be 3 minimum. The quartile 1 would be 3.75. And quartile 2
Okay, is he saying it right? No. Because what's missing?
the number.
Yeah, 3.75 is something, but it's not the number. What is it? What is 3.75 represent? Yeah, it represents the position, but you didn't actually tell me the number. Yeah, so this is between 3rd and 4th. It's between 9 and 12. Just gotta do 9 plus 12 over 2 exactly. That gives you 10.5. Next one. What was it? 15 and 16? 16 and 18? Which one is it? 1, 2, 3, 4, 5, 6, 7, 8. 16 and 18. That's 17. And then for 11.25, 24 and 26. And that's 25. So let's give it.
It's always going to be times 0.25 times 0.5 times 0.5.
Well, yes, and why? Because we're doing quartiles.
Mm-hmm.
So where it's the 1/4 mark, the half mark, and the 3/4 marks. That's exactly why. Yeah. Okay. So what's the 5-number summary now? There you go. Okay. Alright, is that good? Okay. So, what I'd like to show you now is a very quick visual representation of the 5-number summary. So, we talked about lots of visual representations, but this one comes from here. So, this is called the box plot. So what is a box plot? Well, we're just going to mark off So let's mark off our 5 numbers. So the first one is 3, goes here. Next one is 10.5, that goes about here. Next is 17, that goes about here. 25 goes right here, and 29 goes about here. So how do we make this into a box plot? Well, the first quartile goes from 3 to 10.5, that's a flat line. The next one from 10.5 to 17, we draw that as a box. Next from 17 to 25, that's also a box. And then from 25 to 29, that's a flat line. So line, box, line. Notice where each of the 5 numbers is. Each of the 5 numbers is where a line or box starts or stops. So notice that 3 to 10.5, that's the min in Q1, but what does that represent? That represents the first quartile. That's the first quarter of your data. That's represented by this flat line. Next, from 10.5 to 17, that's Q1 to Q2, that's your second quartile. And that's represented by the box. Etc., etc. Okay. So the idea behind this visual representation is that the box part represents from Q1 to Q3, and that is the middle 50% of your data. Maybe it's so it's not very useful, but it's a little useful. So one of the things that it's a little useful for is to say, what is the distribution of my data? Now, for example, you look at this and you say, the left side and the right side, those are about the same. And that's called symmetric. But this doesn't always happen. And let's actually bring in what we talked about last time to talk about what not symmetric would look like. What if Bill Gates walks into the room? What happens? Does the median change that much? Yes, but is the average graphed on here? No. Remember what we did was we found things like the median, right? Remember Q2 is exactly the median. So median Q1, Q3 is not going to change, but what's going to change? The maximum. So what you're going to wind up with is a graph that looks like this. And because of that long tail on the right side, that's called skewed right. So this is a nice visual way of seeing whether or not you have an outlier. Similarly, if you had a very, very small number, you get this graph, and that's called skewed left. And there you go. Outlier on the left, long tail on the left, is skewed left. And there you go. Okay. So, any questions about these things?